to discuss about the characteristics impedance, right? So in that, the wave equation in free space you need to consider, that is the dou square E by dou x square equal to mu into epsilon into dou square E by dou t square. That is the actual wave equation in free space. Okay, so that is the del square E expression, that is the del square E or del square H expression we obtained, that is the wave equation in the conduction medium and free space. Both case we find it the electric field as well as the magnetic field, both the medium we find it, that is the conducting medium and free space. So we are considering the wave equation in the free space, that is the del square E. Here we are consider the dou square x by E by uniform plane wave we consider. So the dou square E by dou x square it should be equal to mu epsilon into dou square E by dou t square it will come. So in terms of velocity, the wave it have the finite velocity. So we consider in terms of two function, that is the electric field it should be equal to, here the wave is traveling in the x direction, we consider the x in both the positive direction as well as the negative direction, that we consider for the two different functions, that is the f1 and f2, that is the negative direction and positive direction we written. So you can take it as the first one is the negative direction. So the velocity, the v, we all know that the v it should be equal to 1 divided by square root of mu naught into epsilon naught. So that is the velocity. So initially we consider the primary function, that is the f1. So we need to find the del cross E. So we know the del cross E, that is the x and y and z are vector. So while we are making the curl of the electric field, we can obtain this expression. But while we are discussing in the uniform plane wave, in the x direction the wave is traveling, so the electric field Hx as well as Ex it is getting 0. Similarly E in the other direction, E in the y direction and z direction, we put the electric field also 0. So that all you can consider this assumption. Then you can substitute in the appropriate place, you can put the 0 and remaining expression has been simplified like that. The del cross E it should be equal to minus y into, because this term is getting 0, the remaining the only this and this term, that y coordinates and z coordinate only these terms are available. So you can write it. So the del cross E we find it. Similarly in the magnetic field also you can find. So based on the cross product you can find the del cross H also. The del cross H it becomes like that. So similarly you need to consider the another expression from the Maxwell equation. Del cross H it should be equal to sigma E plus epsilon into dou E by dou t. But here the conductivity is the 0 in free space. So the equation is getting modified into like that. That is the epsilon into dou E by dou t it will come, right? So you can compare these two equations. The LHS side are both are same. So the epsilon E it should be epsilon into dou E by dou t it should be equal to minus y into dou hz by dou x plus z vector into dou hy by dou z it will come, because LHS side it is same. So RHS side obviously it should be also same. But while we are considering the E vector, it have the three coordinates, that is the Ex and Ey and z vector. While we are writing in the vector form, the dou E by dou t will becomes like this, that is the dou Ex and dou Ey dou Ez vector. Then in terms of vector form you can write like that. So here already we know that is Ex it is 0, so that the value is it is getting 0. Remaining y vector and z vector alone will be there. That we can write it like this, that is here epsilon into, that is epsilon into here the y vector and z vector. Similarly already we simplify the expression, it's have the y vector and z vector. So both y vector and you can equal in both the side, that is the y vector coefficient and z vector coefficient, both are you can equal it and you can get the value of dou hz and dou hy. Wave is traveling in the x direction and h and z direction and y direction, what is the resultant wave you can obtain. Similarly, and another one thing, that is the del cross E it should be equal, that is the Maxwell's second equation. Del cross E it should be equal to minus mu into dou h by dou t. So that equation also you can compare. Here the del cross E is there. So that del cross E equation and here del cross E equation, both are you can compare. As like I already simplified the same thing, you can simplify both z vector as well as the y vector, and the resultant value we can obtain finally the dou Ez by dou x. It should be equal by mu into dou hy by dou t. Similarly, you can find the all the cases. So it means that in terms of permeability you find a two expression, and in terms of permittivity you find a two expression from the first function. Similarly, you can consider the second function, this one that we will derive it now. Okay. Actual expression E it should be equal to, we written in terms of two functions, f1 into x minus v naught into t. Similarly, f2 into x plus v naught into t. See, you consider the both the positive and negative direction. So while you are equating this term, here the negative sign is there, but while you are finding the x direction, x it should be equal to here it is positive direction, here it is the negative direction. Normally we omit the negative direction, the positive direction alone we consider. So the f1 becomes f E equal to f of x minus, that is the function of x minus v naught into t. T is the time, x is the direction, v naught is the velocity of the wave. Okay, so here y ey we consider any one coordinate because x is the direction of the wave. It may travel in the y direction or z direction. So we consider the y direction. So the ey it should be equal to f into x minus v naught into t, right? So here we are taking the differentiation in both the sides. That is the partial differentiation. Here we are already using the partial derivative. So we are using the same differentiation. So dou ey by dou t should be equal dou f by dou of the function x minus v naught into t. Similarly, the dot of with respect to the time we can multiply the both the side. So it may get while we are making the differentiation we can expand like that, right? So that is the dou f by dou the special term, and the numerator and denominator we can expand like that. So the resultant value it may getting, never it will be getting varied. For our convenience we modified like that. So again we can the simplification, that is the f dash of the same expression. Here while we are making the simplification minus v naught it will come. So here dou ey by dou t, here the instead of f dash x minus v naught of t we can write simply f dash alone minus v naught of v naught, we can write it directly, but we already find the some expression minus dou hz by dou hz by dou x equal to epsilon into dou e by dou t. That we derived the expression from the Maxwell's equations. We derived now. So that is the, you see here, that is the first expression. Second thing, and third and fourth we obtained all the expression. Here you see that minus dou h by dou z, sorry, dou hz by dou x it should be equal to epsilon into dou e y by dou t, it may come. Similarly, so you substitute that same expression here, right? Instead of ey by, that is the dou ey by dou t, you can substitute the remaining term f dash of minus v naught. We obtained here itself. So you can substitute it. So the equation becomes getting modified. So here already the one minus sign is there. Here also the minus, it is getting positive. So the epsilon v naught into f dash. F dash is there. That is a partial differentiation. We noted short form. So v naught we know that because here it is the epsilon is there. Epsilon is the permittivity, but here the velocity itself it's have the both permittivity and permeability. So you can replace v naught into 1 divided by square root of mu into epsilon it will come, but the mu r and epsilon r it may getting the value is 1 in free space, so we can eliminate like that. So 1 divided by mu naught into epsilon naught. Here instead of epsilon we can write epsilon naught because the epsilon it should be equal to what it will come, epsilon naught into epsilon r. The epsilon r value is getting 1 in free space. Free space the value is 1, so we can directly write epsilon it should be equal to epsilon naught. That's why here we are replaced. So 1 divided by square root of mu naught into epsilon naught into f dash, right? So here while we are eliminating this term, here it is the already square. The epsilon naught we can write instead of the square root we can, epsilon naught is there, no? So epsilon naught into epsilon naught we can write like that. One term it is getting cancelled. So the remaining term the epsilon naught divided by mu naught alone it may come like that. So dou hz by dou x it should be equal to square root of epsilon naught by mu naught into f dash. So when we need to find the exact magnetic field in the z direction, right? So we need to make the integration with respect to x. So while we are making the integration, here the differentiation it is getting automatically cancelled. So the hz it should be equal to the integration, the constant term you can take it commonly outside, then remaining the integration of f dash into ds, because we are integrating with respect to x. So the differentiation and integration it may getting cancelled. Finally the f alone it will come. But here f, what we are consider f the function of ey. So f we can replace in terms of ey. Okay. So hz by ey it should be equal to the square root of mu naught, sorry, epsilon naught by mu naught. Similarly, if you are obtained the ey by hz, what it will come? The square root of mu naught by epsilon naught. Suppose if you are consider some other medium, here we are considering the free space, that is why the mu naught is came and epsilon naught is came. If it is any conducting medium or some other things, hz it should be equal to the square root of mu by epsilon. Mu by epsilon. That is the equation for the characteristics impedance of the uniform plane wave. Okay. The E by Ez, that is the square root of mu by epsilon, that is the characteristics impedance, that is the electric field as well as magnetic field, both x, the wave is given input is the x direction, the wave how much quantity of electric field is traveled in the y direction and the z direction. Okay, the wave is coming in the x direction, then how it is transferred in the y direction and the z direction. Okay, that you are founded that is the characteristics impedance of the wave. Okay, ey by hz it should be equal to the square root of mu by epsilon. Okay, note it down. Okay, thank you.